All right, so this is our special triangles video. I forget what number we're on, but this is part of our unit circle series. And special triangles are incredibly important when we are talking about trigonometry. So let's first look at 45, 45, 90 triangle. Understand that this is a isosceles. So if we remember from geometry, isosceles means that you've got two sides that are congruent as well as those opposite angles. So a 45, 45, 90 triangle will have congruent sides here for the x and the y. We're looking at a unit circle, which will become a little clearer in the next video, but our hypotenuse is going to be 1. So we can derive the length of these sides knowing the Pythagorean theorem. So in this case, x squared plus y squared is going to be equal to 1 squared. And because this is isosceles, x is equal to y, we can substitute for one of them. So we've got x squared plus x squared is equal to the 1. 2x squareds, so we've got 2x squared is equal to 1. Isolating my x, we get x squared is equal to 1/2. And then finding the square root of each, we end up with x is equal to, technically plus or minus, the square root of 1/2. Now, since we're looking for a length, we don't care about the negative part, so we're just going to go forward with the positive side. Square root of 1 is 1, and we've got a square root of 2 in the denominator. Remember, we cannot leave a square root in the denominator, so we're going to rationalize it by multiplying it by square root of 2 over square root of 2. Remember that this has a value of 1, and we can multiply by 1 without changing the value. So we're just changing this form to the square root of 2 over 2. Our second special triangle actually starts as an equilateral. Now remember, an equilateral triangle, I always forget whether it's 2 L's or 1. I think it's 1. An equilateral triangle has 3 congruent sides. Equilateral triangles are also equiangular, so all of the angles are going to be congruent as well. Now we know that the sum of the angles of a triangle is 180, so that tells me that each of these angles is 60 degrees. So now if we take this equilateral triangle and cut it in half, so we cut this straight down the middle here, we end up with 30 degrees here. Here's our 60, and that makes this a 30, 60, 90 triangle. So looking at this 30, 60, 90 triangle, again, we're going to start with a hypotenuse that is equal to 1. Now, because this is half of that equilateral triangle here, that means that this length here, the short side, is going to be half of the hypotenuse. So at this point, we know that x squared plus 1/2 squared is going to be equal to 1 squared. So x squared plus 1/4 is equal to 1, or x squared is equal to 3/4. Taking the square root of both sides, again, technically we get plus or minus, but we don't care about the minus side because what we're looking for is a length, and we get the square root of 3/2. You're going to see in our next video how we place this in the unit circle. So if we've got a circle here, that's not a very good circle, is it? But if we set our triangle where the angle, the vertex of that angle is at the 0, 0, with an initial side that coincides with that x-axis. If this was my 45, 45, 90 triangle, I know that this is the square root of 2 over 2. This is square root of 2 over 2 because this is that 45 degrees, which means that the coordinates here will give me square root 2 over 2 and positive square root 2 over 2. The same way a 60-degree angle will intersect with the unit circle at 1/2 square root 3 over 2. We'll get more into the unit circle in the next video. I'm not a big proponent of memorizing everything, but your special triangles, it will make it so much easier for you in the long run if you can commit the 45, 45, 90, and the 30, 60, 90 to memory. And in that way, you'll be able to work on the new stuff, the trigonometry part, without having to rederive these triangles each time you get a problem.